In school, we all have learned that plants produce oxygen through photosynthesis, a process that requires sunlight. So, it means that without sunlight, oxygen production is simply not possible, right? Well, that's not entirely true.
Serious?
Hey everyone, today we're going to talk about a groundbreaking discovery that challenges our traditional scientific understanding. This discovery is called dark oxygen. It's a term used to describe a new phenomenon in science and deep-sea research. But before we dive deeper into this fascinating topic, don't forget to hit that subscribe button and ring the notification bell to stay updated on our latest videos. Let's break this video down into two parts. In the first part, we'll dive into the concept of dark oxygen. Then, in the second part, we'll explore an environmental concern linked to this discovery and discuss potential solutions.
You are having me on. You are definitely having me on. No, you are.
We used to think that the deep sea was only a consumer of oxygen. The oxygen we breathe every day is produced by plants through photosynthesis, which requires sunlight. But recent studies have made a surprising discovery. Deep-sea sediments and polymetallic nodules are actually producing oxygen even without any sunlight. This finding is particularly significant in the abyssal plains of the Pacific Ocean. But why is this oxygen called dark oxygen?
Why?
It's because it's being produced in the abyssal zones of the deep sea, places where sunlight never reaches and temperatures are near freezing. The fact that oxygen can be produced in such extreme conditions makes this discovery truly remarkable. While the exact mechanism behind dark oxygen production is still a bit of a mystery, scientists have a couple of leading theories. The first theory suggests that oxygen is created through a process called radiolysis. In radiolysis, radioactive materials decay, breaking down water molecules H2O into hydrogen and oxygen. Deep-sea sediments contain radioactive elements like uranium and thorium. The decay of these elements could trigger radiolysis, providing a source of oxygen in the deep sea. The second theory proposes that oxygen is produced through electrochemical reactions in the deep sea. Imagine deep-sea polymetallic nodules and sediments acting like natural geobatteries. These nodules are rich in metals like manganese, iron, and nickel, which can create an electrical potential. This potential can then kickstart chemical reactions in the surrounding seawater, leading to the release of oxygen. To put it simply, a geobattery is like an electrochemical system that uses chemical reactions as its power source. It's similar to a regular battery, but instead of converting chemical energy into electrical energy to power a device, it's using that energy to create oxygen in the seawater. This discovery has also shed new light on the ecological impacts of deep-sea mining. Deep-sea mining involves extracting minerals like polymetallic nodules from the ocean floor. These nodules are highly sought after in today's global economy because they're rich in metals such as manganese, nickel, copper, and cobalt, which are essential for modern technology, especially electric vehicle batteries. However, if this mining isn't carefully managed, it could upset the balance of ocean ecosystems.
I suffer from short-term memory loss
And disrupt the production of dark oxygen. Removing these nodules, which play a role in dark oxygen formation, could have harmful consequences for the fragile deep-sea ecosystem. So the question is it ethically right to disturb deep-sea environments, especially when it could impact dark oxygen production?
No. No.
Let me know your thoughts in the comments. Now let's just explore why this isn't a good idea and also discuss some potential solutions. Disrupting oxygen sources in the deep sea can affect not only marine life, but also the entire oxygen cycle. Organisms in abyssal zones have adapted to live on low oxygen levels. If dark oxygen production is hindered, these creatures could be in danger. These ecosystems are incredibly delicate, and we need more research to fully understand them. It is evident that deep-sea mining is on the rise, but the full ecological impacts are still unknown. If mining disrupts this process, the long-term consequences could be severe, so it's crucial to act responsibly now. And for that, we need international regulations to control deep-sea mining and minimize ecological damage. Focusing on sustainability and taking steps to protect nature is essential.
Are you proud of these sites? Of course you are. But are you proud of what we have done to them?
Also, raising public awareness about the risks of deep-sea mining can help us create more responsible policies. Technological innovations, like less invasive mining techniques, can also reduce environmental impacts. Ultimately, global collaboration is the key. Oceans belong to the entire world, so we must work together to protect them. Understanding the mechanisms of dark oxygen production should be a priority for future research, allowing us to better understand oceanic oxygen cycles and their ecological impacts. The discovery of dark oxygen has introduced a whole new perspective in science. Not only is it significant for deep-sea ecosystems, but it also shows us that there are processes happening on our planet that we're still unaware of. This discovery reminds us of just how complex and surprising nature can be, and there are many more mysteries out there waiting to be explored. If you found this information interesting, please like, share, and subscribe. We'll continue to bring you more mysterious and groundbreaking discoveries. Until next time, plant lots of trees and keep breathing in that fresh oxygen. Bye-bye.